alaikum wa rahmatullahi wa barakatuh. Dear students, hope you are doing great. Today we will continue the next part of questions for Kangaroo for questions for year 2022. Let's start. Question 11. Question 11 here. As you can see, we have 5 big elephants and 4 small ones are walking along a path as shown in this picture. Now, when they reach the junction here, each elephant turns either to the left or to the right. Which of the following cannot be the situation after they all pass this junction? Now, let's see options. We have option A, B, C, D, and E. If you look to the elephants here, starting the big one, then the small, maybe big, another big, and so forth. At the end, I must see the small elephant appears either at the end of this junction or at the other side. Now let's see the option. This one has one small elephant at the end. Here we have at least one. Other options, here we don't have, here we have, and here we have at least one. That means C is the option that cannot be the situation after all elephants pass this junction, because I couldn't see the small elephant either on this side or on the other side. So C is the right answer. Moving to question 12. Let's read and see how can we solve. Yara starts with 12 and follows the arrows using the rules shown here in the picture on the left, on this side here. Now, what number will she finish with? Let's see the rule and let's see the shape. Here is the rule. Moving to the right or moving to the left, you divide by 2. Moving to the right, multiply by 2. Moving up, divide by 4. Moving down, multiply by 4. That means what? If I move one step to the right and one step to the left, those are opposite effect. We have opposite effect here, and the result is 0. It's the same. So, similar to that, up and down, using the same value. Multiply by 4, divide by 4, you still have the same number, so the effect is 0. Now, let's see the number here, and let's see the path that she followed, and let's guess what would be the number here. So, up, down, they cancel the effect, opposite effect. Again, up, down, nothing. Here, again, up, down. I don't have anything changed on 12. Now, right, left, or left, right, right, left, again. The only remained arrow here is the arrow moving to the left. That means dividing by 2. So, your answer will be 12 divided by 2 equals to 6. And B is your right answer. This is how can we solve this in a short way. Moving to the next question. Good one here. We can see 2022. And let's read the question. Masoud and his friends built the number 2022 with 66 cubes. Here, if you count them again, of course, you can see that those are 66 cubes. Now, they painted the whole surface of the structure yellow. How many of the cubes have exactly 4 faces painted yellow? Now, any cube here, it has 6 faces. But in order to paint the surface, they might not need to paint all faces, since they will join them together in order to make the 2022. So let's see that how many of those cubes will have exactly 4 faces painted. If you start here, check 1, the face here, 2, 3, 4, and the left one here, 5. This has 5 faces painted in yellow. So it's not 4. Check the next one. 1 in the back, 2, 3, and 4. Those were not painted. So those inside the shape, they have, all of them, they have 4 faces painted in yellow. While this one, the ends, each cube here has 5 faces painted in yellow. In here, in the 0, it's a closed shape. So 1, 2, 3, and 4. 5 from here and 6 there. It's painted only or exactly 4 faces. So this is closed shape. So all of cubes used here are painted in yellow only for 4 faces only. So here 2 repeated 3 times. That means 1, 2, 3, 4, 5, and 6. 6 cubes have more than 4 faces. Actually, they have, each one of them, 5 faces painted in yellow. So I have 66 cubes minus, as we said, 6 cubes. The result is 60 cubes are exactly, or 60 cubes, they have exactly 4 faces painted for each one of them in yellow. So the result is 60, which is E. So E is the right answer. Now moving to question 14. A rectangular based water tank has dimensions of 1 meter times 4 meters times 2 meters. And it contains water of a depth of 25 centimeters. So this is 25 centimeters, as shown in the picture here. Now the tank turned, so the base now became 1 meter times 2 meters. Now we need to find how much would be the depth of the water now. So first of all, since this is 25 centimeters compared to the total depth or height of this shape, so divided by 100, that makes quarter. So the amount of water filled here is quarter of the total volume of that shape or that tank. So when we turn the tank using the base of 1 times 2 here, that doesn't make any difference and the volume of the water will stay the same. So what we have to do, we have to find how much would be the depth of the water here. We know that it's quarter of the tank. So I have here, what have been changed here? The total height or depth is 4. Now, as we agreed that the amount of water is quarter of the total volume of the tank, that means quarter of the 4 equals here 4 over 4, that makes 1 meter, which is the depth of the water here, which is 1 meter. Let's double check if it's 1 meter, and it will be D is the right answer. Let's double check here. How much is the volume of the water here? It will be 25 over 100, which is this much, times 4 times 2. That makes quarter times 4 times. So again, this is the volume, 25 over 100, which is quarter, times 4 times 2. That makes here 2 meter cubed. Now let's check the volume. Here we have the base 1 times 2 times the depth that we found, which is 1. 1 times 2 times 1, which is 2 cubic meter, and it's the same volume, so the 1 meter is the right answer. Moving to question 15. Now, here we have this shape, and in the picture here there is a piece of transparent paper with a design. Here, this one and this one drawn on it. Now the paper is then folded twice. They gave us the direction here. They will fold it this, then that. So what would be seen on the folded paper? So at the end, we will have a square like this, but we need to know what would be the final design on that piece. So folding this, you have to imagine now and work on the reflection of the shape. So imagine that this will be like here, so this will be here, and the line, can you see, like this, fold it like this. Let me erase here so we can see it. So it will be like this. Now what will be the direction of the lines when you flip this one here? It will be this. Now we need to fold it on the other side like this. Imagine now we can see here, we can see only this shape here, and we need to fold this on the other side. So this line will be here. Here. Exactly on this line. And this here, this triangle will be where? Will be here. So basically we can't consider this, we can't consider this, we can't consider this, and I have here two options. But which one is the right one? This depends on the direction of the orange colors. Orange color here. So when this turned into here, it will have the same direction. And which one here? Which one is the right answer? It will be A is the right answer, because this is wrong because of the direction of the orange lines here. So A is the right answer. Moving to question 16. Moving to question 16. Now, in question 16, here we have a big square. It has the dimensions 10 centimeter, which is the length of the side. Now let's see. The area of this would be 10 times 10, which is 100 square centimeters. Now what is the area of the shaded figure? This one in orange. So let's see. You can think about this in many different ways. I will give you two ways. Let's start by dividing this here in the middle. Let me draw it in a better way. And on this side here, like this. So, if you look here, those are quarter, 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 quarter. If you check here, how much will be the area of the shaded figures, you can see that here I have this right triangle, and I can guess that this is a quarter of any square here. So here 1, 2, 3, and this one can fit here. So if you fit so this one here, this one, and this one. So we have another square here inside. How much is the area of this square? Let's see. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So it's 1, 2. That means it's like this. It's the quarter of the shape. So how much is the area for the whole outer square? It's 100. And this one represents quarter of the area. That means we will divide this by 4. So it will be 25. Oops. 25, of course, squared centimeters, which is B, will be the right answer for your question. Now, moving to question 17. Before that, we said that we have here maybe two ways. The first way is to start dividing using those lines in order to divide it from the middle of each point here, or directly you can figure out that those square or those triangles can complete the shape, as we explained as another part of the solution. It can fit here, and you can of course complete your solution as we did here, so that the shaded or the area of the shaded part is quarter area of the outer square. Now we can move to question 17. This is a nice question. Let's move. Now the year 2022 is a special year because the digit 2 appears 3 times, as you can see here. Now, this is the 3rd time Najiba, the tortoise, has lived through such a year with 3 identical digits. So, Najiba is a turtle, and she lived through such a year with 3 identical digits. So, she faced this 3 times in her life. Now, what is the youngest Najiba could be by the end of 2022? Now, we need to look and see what are the number or what are the years that passed or that Najiba passed during her life in order to see 3 digits or 3 identical digits in the year. The first one was 2022. Moving back 2021, 2020, up, you will reach 2000. Other, you may find 2 identical digits, but when we talk about 3 identical digits, so here 3 zeros, here 3 twos, and moving back 1 year, you will find 1999. And here we can see that 9 also appeared 3 times. So, the youngest that Najiba can be or could be, starting 1999 up to by the end of 2022, what would be Najiba's could be by the end of this year? Let's count. From 2000 to 2022, this is 22 years and 1 year here. That makes D is the right answer, which is 23 years old. Now, let's move to 18. Now, Bender wants to complete the picture so that each row, each column, and each set of 4 circles connected by line segments contains the 4 numbers 1, 2, 3, and 4. Let's explain this on the picture. So here we have each line, each row, each column, and can you see 4 circles connected by line segments? So we want the 4 numbers appeared on those 4 circles, and we don't need any number to be repeated either in the row or on the column. Now, what number should be right, or should he write, Bender, should he write in the circle that has the question mark? Is it 1, 2, 3, or 4, or I cannot decide? Now, let's see. Here, on this row, I need to guess what are the numbers here. Since I have those connected by line segments, we said we need to see the 4 numbers. Here I have 3 and 2, so here I have either 1 or 4 to have 1, 2, 3, 4, or 4 and 1. It doesn't matter for me because I just need to know what are the numbers can be occupied here. Moving to the other side, which is the number that I need to know, it's 1 row. And we said we need to see all numbers in 1 row and 1 column. So since this is 1, 4 or 4, 1, I need to see either 2, 3 or 3 and 2. Now how to decide? We said check the column and the row. The row we agreed on 3, 2 or 3, 2 or 2, 3. Now here I can't put 2 because 2 is repeated here. So this definitely 3 and this one is definitely 2. So the number that can be instead of the question mark is B, which is number 2. Next question. Here we don't have pictures. Now let's see. Layla has 4 dogs. So I have dog number 1, number 2, number 3, and number 4. Each of the dog or each of the 4 dogs weighs an integer number of kilograms. Integer means I must have whole number. We don't have fractions of kilograms. No 2 of them weigh the same. So 1, 2, 3, 4, 14, 15, and so forth. And we don't have any 2 dogs weigh the same. Their total weight is 60 kilograms. This is the total. If we add the here 1, 2, 3, and 4, it's 60 kilograms. Now, the second heaviest. So we have the heaviest, second heaviest, and third heaviest, and here the last one, which is B, the lightest here. Now, the second heaviest dog is 28 kilograms. So this one is 28 kilograms. How heavy is the third heaviest dog? Now, let's see. Since the sum of all weights here is 60, I need to subtract to see how much left for the other 3 dogs. So 60 minus 28, that makes how much? 32. Okay, now 32. We need to assume I have the heaviest dog. That means the heaviest dog definitely more than 28. But by how much? At least by 1. Because we said the weight is an integer. So this one can be 29, 30, 31, or 32. Because the difference is 32. If it's 32, that means 0 and 0. That means there are no dogs, and this is not acceptable. If it's 30, it will be 1. What about the other? And we said it's an integer. That means no halves, no partial kilograms. Also, this is not acceptable. Now 30. If this is 30, I will have 2 kilograms left. That means 1 and 1. But they said that no two of them weigh the same. So they can't have the same weight, 1 kilogram and 1 kilogram. So 30 is not acceptable. 29 is the suitable number of the heaviest dog. So 29, that means I have left here, if I subtract 29, I will have 3 kilograms. 3 can be 2 and 1. So 2 kilograms and 1 kilogram. So the third heaviest dog weigh 2 kilograms, which is option A in this question. Moving to question 20. Question 20. Mayar writes the 7 numbers 3, 4, 5, 6, 7, 8, and 9 in the circles in the shape shown here, so that the sums of the 3 numbers on each line are equal. So this line, and another line, we need to find the sum. The sum must be equal. What is the largest possible sum of the 3 numbers on the line that Mayar can get? I have numbers from 3 up to 9. In order to make the largest possible sum, I must use the largest number to be in the middle. This is the key here. 9 must be in the middle to be added to the other numbers on the line. Now, you have to move backward. I will choose 7, 8, and 6. Now, here, I moved backward 8, 7, and 6. Now I still have 5, 4, and 3. Logically speaking, I need to add the 5 to the 6 because it's the smallest number used. And we will check. 4 will be with the 7. And the smallest number would be added to the largest number that I have chosen after, of course, 9 that comes in the middle. Now, let's add and double check. Do I have same sum on each line? Here, 9 and 6, 15, plus 5, that makes 20. The other line, 9 and 8, 17, plus 3, 20. 9 and 7, 16, plus 4, 20. Now, if you choose any number else rather than 9, you can't find a sum like 20. You will reach, or you will have lower or less than 20. Why? Because the biggest number is added to only one line. While here you have used the maximum for 9 to be added to all lines, and then you distributed the others. If you choose, for example, 6 here in the middle, you may have 18. 3, you may have 16. If you try any other combination of numbers, you will find definitely a number that is less than 20. And don't forget, you must have an equal sum on the 3 lines. Some of you will think, okay, can I put 9, 8, and 7? Those are the biggest numbers here. Of course, if you put them and add, you will find that 9 plus 7, or 9 plus 8, 17. 17 plus 7, that makes 24. If you put other numbers here, you will never get 24. The maximum number you can have is 20. So 20, which is E, will be your right answer for this question. And question 21. In question 21 here, we have some glasses. Some glasses here are stacked on top of each other. A stack of 8 glasses. This is 42 centimeters. And the stack of 2 glasses, as shown here, is 18 centimeters. Now, they want us in this question to find how much or the height of the 6 glasses stacking to each other. So let's think. Those are 8 and those are 2. So 8 minus 2 equals 6. So if I subtract 42 minus 18, that makes 24 centimeters. But this is not the height for the 6 glasses. Can you see here? If you subtract this out of this, you will have only this height. The height of what? The height of the shown top of each glass. This plus this plus this plus this plus this plus this. So 24 centimeters actually divided by 6 glasses here. That makes 4 centimeters only for the top that is appeared from each glass. Moving back to this part, that means that this one here is 4 centimeters and another top for the other 2, which is 4 centimeters. So 4 plus 4 equals 8. 8 out of 18. That makes the hidden part here that we couldn't know what is the height of this part of the glass is 10 centimeters. So let's see how much or how high would be the 6 or the stack of 6 glasses. 1, 2, that means 10 here and 4, 5 times 1. This is the first glass, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, 6. 6 times 4, which is 24, plus 10 centimeters, which is the basic part appeared from the first glass. That makes 34 centimeters, and that makes your right answer for this question. Question 22. Let's see this picture. It has many animals here. Each animal represents a positive integer, and different animals represent different integers. The sum of 2 integers in each column is written here. So integers again here, that means we have whole numbers, and they said those are positive integer. That means positive number and not 0, of course, because they said it's a positive integer. Now let's see the sum of each 2 integers here, 15, 11, 3, and 7. And here we need to know what is the largest possible sum of the integers in the first row here. When I add those, how much would be the largest possible sum? Let's see. I can start actually from this one here because it's the smallest sum, because 3 equals 2 plus 1. I don't have any other option. And to make this row or to enlarge the sum, I must put the biggest number of each sum of two numbers here on the first row. So 2 and 1, I will put 2 here and 1 here. So 1, 2. Now what comes after 3? 7. What gives you 7? 3 plus 4. 3 plus 4, and we are not repeating because they said each animal represents different integer. So 3 and 4, as we agreed, the biggest number must be on the top row. Now 11. What gives me 11? I have many options, but since I reach 4, I can find that 5 plus 6 equals 11. That makes 5 here, 6 on the top, and the last one 7 and 8. Now let's add the numbers on the top. That makes 10, and that makes another 10. That gives me the sum of 20, which is the largest possible sum of the integers here, of the numbers that we have found. Now moving to question 23. 23 here, to unlock this lock, you get the following 4 units here with some information given under each one. Now, what is the correct code for the lock? Now, let's see. We have 604, 082, 640, 042, and 046. Now, let's see the information under each lock here. In here, I have one of these digits is correct and in the right place. So we have one correct digit and in the right place. On the other side here, I have one of these digits is correct but in the wrong place. And I can see that 6 repeated here. 2 of these digits are correct but in the wrong place. Again, wrong place. 6 appeared here also. And the last one, all of these digits are incorrect. So 7, 3, and 8 are incorrect. So here, 8 is incorrect. And let me see. 8 here appeared in B, so I can exclude B from my options. Now, from the options here, I couldn't see 1, so also 1 is excluded. Okay, so I have other numbers, and let's see. Here, they said that one of these digits is correct and in the right place. If I see that here, if I assume that this is 6 here, so 6 is correct and in the right place. Here, they said there's only one digit correct, but it's in the wrong place. So if I assume that this is 6, that means 6 is not my answer because those two information are opposite. If this is in the correct, if this is in the right place, that means if I assume that this is in the right place here, it couldn't be here. That means I can't use 6. So I have here 2, I have 4, and I have 0, and we excluded 6 also. So I have 0, and I have 2, and I have 4. Now, if you look here, A, it has 6, C, it has 6, and E, it has 6. So D might be my right answer, but let's double check if it's the right answer or not. Now, since here one of these digits is correct and in the right place, that means 2 is the first digit here. And they said 2 of these digits are correct but in the wrong place. So 2, we agreed that it's here. I have 0, so 0 either here or here. Now let's see here, one of these digits is correct but in the wrong place. So here, since this one is not in the right place, so here, correct, but we can switch their places. Zeros here, and at the end 4. It's correct number, but it's in the wrong place, and this is the place for 4, and 042 is the right key for this lock in order to be unlocked. So D is the right answer. Moving to question 24. Lion has the shape shown above, or it's beside here. Which of the following shapes is the same as Lion's? Now let's see, we have 3 bars, 1, 2. Each bar contains 3 cubes, 1, 2, and 3. Now you can see that one bar is connected or glued in the middle to the other bar. So, and 1 to the side. If we say that this is the front side, so 1 to the front and 1 to the right side. Now let's check here. This one is glued at the first cube here, so this one is not. Again, this one here, those are glued. Can you see the glue here? One in the middle, but one at the edge, so also this is not the correct one. Here, in the middle, this is correct, but let us check the other one. In the middle and in the middle, this is also correct. Here, in the middle and at the edge, this is incorrect, but we couldn't have 2 correct answers. Can you see here? We said in the front and to the right. So here, this one, front to the right. This one, front and in the back. So this is not the correct answer, and C is the right answer. Front and one of the side, or back and left. We must see the same position even if they turn the shape into other direction, but we must see the same conditions repeated in the shape or our option. So C is the right answer. Now question 25. Amir chooses 4 of the numbers 2, 3, 4, 5, and 6, and writes 1 here in each box so that the calculation is correct. So I have 1, 2, 3, 4, and 5. He chooses 4 of the numbers to be written here, and 1 appears here. To have correct calculation, adding the first 2 numbers, subtract another number, and we must see the result here. How many of the 5 numbers could Amir write in the shaded box? Now let's start. Here, I may start with number 2, for example. Let me use this side. So if I use 2 plus, for example, 4, 2 plus 4 here, or 2 plus, let me erase. Okay. 2 plus, for example, 6, minus, for example, this is 8. 8 minus 3 equals 5. So 5 appeared here. Maybe 2 plus 5, 7. 7 minus 3, that makes 4. So I have 5 appeared, 4 appeared. Let's see. 3 plus 5 minus 2. This is 8 minus 2, that makes 6. So 6 also appeared. Now 4 plus, for example, 4 plus, let's try 3. That makes 7. 7 minus 5, 2. So also 2 appeared. Let's try to find another combination if we can have 3. Now 6 plus 3 minus 9, 9 minus 5. That makes again 4. No, we need something else. Maybe we may use 5 plus 3 or plus, that makes 8. 8 minus 4 is 4 again. Maybe 6 plus 2. 6 plus 2 minus 4. That makes 4 again. Minus 5. Minus 5. Yes. 6 plus 2 minus 5. So 6 plus 2, that makes 8. 8 minus 5 equals 3. So 3 also appeared. So 3 or 2, 3, 4, 5, and 6, all the 5 numbers appeared. 1, 2, 3, 4, and 5. So E is the right answer. So in this question, you need to try the combinations, different combinations, in order to find, is it possible to find 2? Is it possible to find 3? And so forth. Now, question 26. Numbers 2, 3, 4, 5, 6, and 7, not 2, sorry, numbers 3, 4, 5, 6, and 7 are to be placed in the 5 circles here as shown, in order that the number inside each triangle is the product of the 3 numbers. So if you multiply those 3 numbers, which is the product will be here for 84, 105, 210, and 168. Now, what is the sum of the 3 numbers on the vertices of this triangle here? So in order to find those numbers, what we have to do, we need to find the numbers here, and we have to add them in order to find what will be the sum. Let's see here. I have numbers 7, 6, and we are talking about product. So in this case, you need to try to find the divisibility rules. You need to use them. So those, if you add all those digits here, you will find out that those are divisible by 3. Also, those 2 numbers are divisible by 5. So 5 can be shared between 210 and 105, and so forth. For me, I need to focus on this triangle only. So I may use here maybe repeated division, or you can use the tree to find the factors for this 168. So 168 is divisible by 3, as we can see here, and this is divisible by 4. If you don't know the divisibility rule by 7, we can rely on divisibility by 3, and since this is also divisible by 2 and it's divisible by 3, that means it's divisible by 6. So it's up to you. If we start by 4, that makes 42. What gives me 42? It's 7 and 6. Those are the factors. I used the prime factorization tree in order to find only factors, not prime factors. You can use the same here. If you divide again here by 4, you will have 42. The 42 is divisible by 6. by 7, it's 6, and 6 is 1, and those are the factors. I'm not looking for prime factors. So 7 times 6 times 4, that gives me 168. So what is the sum of 4 plus 6 plus 7? That makes 17, which is D. And for your information, all those numbers here, products, are divisible by 7. So 7 will be in the middle here, the middle, which is the factor for each of those numbers. And here we have 6, we have 4, and 6 and 4 can be this one here. Also, this one is divisible by 6. So you can put 6 and 4 here. Of course, in your spare time, you can work for other numbers. But for the question, we have just focused on the triangle that is shaded in blue in order to find the sum of the numbers. Question 27. Question 27 here, which of the following nets cannot be folded into the solid that is shown here? Now, let's see in the shape here in our solid, we have horizontal and vertical minus sign, okay, and one side is a plus sign. Now, let's see options here. If you fold this, try to imagine you will have those two vertically here, and this one will be on the side, which is the same shape here. Again, this one, if you fold it, those will be here again, and this one on the side. So correct. Again, those, when you fold this here, this will be here on the side, and this also be, because we have horizontal and vertical sign. Let's see B. B here, when you try to fold this anyway, can you see there is a different directions for the negative sign or the minus sign? So if you try to fold it and fold those, you cannot find the same exact situation like here. So this is incorrect. Here is the same when you fold it, and those will be here, and this one will be on the side. So this one is right. B is the only net that cannot be folded to show the needed solid here. And let's put here, sorry, B will be the right answer. We highlighted the wrong one. Of course, B is the net that cannot be applied. Okay, question 28. Now we have 4 villages, A, B, C, and D, lie along a road in that order. So we have village A, village B, village C, and village D. Now, the distance between neighboring villages is 10 kilometers. So, distance here is 10, 10, and 10 kilometers. There are 10 students who live in village A, 20 students who live in village B, 30 students live in village C, and 40 in village D. So we have 10 students, 20, 30, and 40 students. The villagers want to build a school so that the total distance traveled by the students when going to school is as small as possible. Where should they build the school? Options: in A, in village A, or in village B, in between, the middle between B and C, in C, or in D. In this question, we have to calculate, we have to find the total distance based on the given distances here and the number of students, because they need the total distance traveled or walked or moved by the students to be as small as possible. Now let's move to A. We'll write A here. If the school in A, if it's in B, here between B and C, B and C, and in C and in D. What we have to do, if it's an A here, all the students will be coming here. So in A it will be 40 students moving 30, so it's 40 times 30, then 30 times 20, then 20 times 10. Times 10. Now let's calculate. This is 1,200 plus this is 600s and this is 200s and 200s. That makes 2,000s. 2,000s here measured in kilometers. This is in A. In B, 10 times 10 plus those will not move. Now those are 30 times 10 and 40 times 20. Let's calculate. This is 100 plus 300s plus 800s. Now that makes 1,100, 1,200s. Now in the middle between B and C, which is here, that makes 10 students will move here. 10 plus 5, that makes 15. So 15 times 10 plus 20 times 5 plus 30 times 5 plus 40 times 15. Let's find the answer. This is 150 plus 100 plus this is another 150 plus that makes 600s. Let's add. Those are 300, 600 makes 900 and 1,000. Now in C here, 10 times 20 plus 20 times 10 plus nothing here and 40 times 10. That makes 200s plus 200s plus 400s. That makes 800s. There is a potential here in C. And the last one in D, 30 times 10 plus 20 times 20 plus 10 times 30. Let's calculate here. 300s plus 400s plus 300s. That makes 700s, 1,000 and 100. No, this is 1,000. 300, 300, 600, 600s and 400. That makes another 1,000. 1,000 kilometers here. So the least or the smallest possible distance that they can move in this question is when the school, if they build the school at village C. So C, D is the right answer in C, if they build the school in C. Now moving to question 29. In 29 here, there are 3 pictures shown here for top, front, and right view for a structure that made of cubes as shown here. Now, we need to know what's the maximum number of cubes that could have been used in order to build this structure. Now, let's see here. I have 1, 2, 3, 4, and I can see from the top view 4, so it's 4 by 4. So I will draw, in order, since I have 3 here, 3 levels, 3 layers, I need to draw the view for each layer separately. 1, 2, 3, 4. It's a 4 by 4. 1, 2, 3. Let me repeat this here again. So 1, 2, 3, 4, 1, 2, 3, 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And I will start looking for the bottom layer, the middle layer here, and the top layer. So imagine that you're looking to the side view of the that structure. Here I can see from here, the bottom layer here, I can see 4. So I can see 4 rows from here. When you look from the front view, you can see 4 rows also from here, from the front. Now, from the top view, I can see some empty places. So from the top view, I cannot see this, and I cannot see this one here, I cannot see this from here, and 1 and 2 from here. So this is the bottom layer of the structure. Moving to the middle one, again, 1, 2, 3. I can see 3 cubes to this side, 1, 2, 3. That means here it's empty alongside my view. So this one is empty. I'm looking from this side. Now from the front side, those I can't see. This and this. So I can see those from my front view. Here at the top view, let's double check here. This one, I can see those here, and those are correct because it's the middle layer, and those are still there in here. Now moving to the top, which is the top layer. Here I can see 2, and the other 2 lines from this side I can't see them. So 1, 2, and those I can't see, and this one here I can't see those. So I will complete here, and again still from the top view I can see still the first part, which is the base of the structure. Now let's count how many cubes we may use here. 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and it's B, which is 19 squares. Again here, those are 9 cubes, and here 6, and here 4, so that makes 19 cubes. They may have been used in order to build this structure. So the idea is how to imagine this shape. Since I have three layers here, I start layer by layer and see how can I see this from the side view, how can I see this from the front view, and what about the top. Top helped me in order to see what can I see from the top, which is the base for me? I can see those either this appeared here or at the bottom of the shape. And the last question in this group for 2022 is question 30. 30 people are sitting around a circular table. Now, some of them are wearing a hat. Those who do wear a hat always tell the truth, while those who do not wear a hat can either lie or tell the truth. Now, each person says, at least one of my two neighbors is not wearing a hat. So, what's the largest number of people who could be wearing a hat? So, around the table, they start, for example, by number 1, 2, 3, and so forth. Now, each one said at least one of my two neighbors is not wearing, at least one. So, if we assume that N means not wearing and H means wearing the hat, so each one said at least one. So, at least, that means not wearing, so wearing and wearing, so NHH. And the next one, wearing, he said at least one is not wearing, so this one is wearing, so not wearing, wearing, and wearing. Each one of those 30 people said the same. So, if you start the first round making this, you will have this theme repeated 10 times, or this order of like not wearing, 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 because we said at least without any ordering. So, not wearing, 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 not wearing, wearing, wearing. For 30 people, we will have 10 at least will be not wearing hats. So, how much will be the largest possible number for the people whom wearing hats will be, those are 10. That makes people are wearing hats or wearing hats 20 people, which is D, and D is the right answer for this question. And this is the last question for this group of questions for 2022. It was my pleasure to have you here for this session. Have a great day and good luck for everyone.